Hello viewers, welcome to UNC Digital class. In today's class, I am going to discuss about queue in data structure. We have already discussed about stack, and in queue we will be based on the principle that is FIFO, that is fast in and fast out. That means though the element which is inserted into the queue fast, that will be removed from the queue fast. Okay? And in real time we can take example of queue. Suppose the peoples are waiting in a queue, that means the people which are waiting first, that people will get the facilities first, then the last people will get the facilities last. Okay? So, this is the principle about queue, and in this class we will be discuss about what is queue, some example from queue, and the insertion procedure, that is NQ and DQ operations in queue, and the array implementation of queue. Let us see the queue operation in data structure. So, queue can be defined as an order list which enable insertion operation to be performed on one end, that is called rear end, and the deletion operation be performed at another end, that is front end. Okay? But in stack we will do insertion and deletion operation in one end, which is the top of the stack, and in this way queue is differ from the stack, that is the insertion done in one end and the deletion is done in another end. So, this is the one end where we want to insert the element into the queue, that is known as NQ, and when we want to delete the element from the queue, that will be performed in another end, which is called as the DQ. And you can see the queue is based on the principle of FIFO, that means the element which is inserted into the queue first, that will be removed from the queue at first. Okay? So, queue is referred to be as fast in, fast out. For example, people waiting in a line for rail ticket form a queue. Okay? So, next we will see the applications of queue. Due to the fact that queue perform action first and first out basis, which is quite fair for ordering the action, and the various applications of queue are widely used as waiting list for a single shared resource like printer, disk, CPU. So, these are one example of queue. In case of CPU, the processor which was come fast for the processing, so that will be processed fast. So, in this way, in this case we can implement queue data structure. So, queue are used in asynchronous transfer of data, where data is being transferred at the same rate between the two processes, for example, the pipes, file IO operations and sockets. Queue are used as buffer in most of the applications like MP3 media player, CD player, etc. And queue are used to maintain the playlist in media player in order to add and remove the song from the playlist. Queue are also used in operating system for handling the interrupt. So, these are the some applications where we can implement the operations of queue, or these operations are based on the queue data structure. Okay? And the operations on queue, in queue we can insert the element into the queue and we can also remove the element from the queue. So, the two fundamental operations performed on the queue, that is NQ and DQ. You can see when we want to insert the element at the rear end, we have already told about that. At the rear end the insertion procedure is going on, and at the front end the deletion operation or removing of element from the queue is going on. So, NQ is the operation through which that is used as to insert element at the rear end of the queue and it returns void. As well as DQ is the another operation we will perform over the queue, and by DQ operation the deletion from the front end of the queue will be done. It also returns the element which has been removed from the front end, and it returns an integer value, and the DQ operation can also be designated to void. So, then another some operations are there, that is peak and the queue overflow and queue underflow operation. Peak means this is the third operation that returns the element which is pointed by front pointer in the queue but does not delete it. Okay? And as like stack, queue also comes to the overflow situation as well as to the underflow situation. So, the overflow situation is called is full, that means there is no space to insert a new element into the queue. That is, when a queue is completely full, that means the queue meet the maximum size, then it shows the overflow condition. And in case of underflow, when the queue is empty, that means there is no element in the queue, then that situation of the queue is called as the underflow situation. That is, no element are in the queue, then it throws the underflow condition. So these are the some operations, that is NQ operation when we insert the element, DQ operation when we delete the element or removing the element from the queue, peek operation that returns the element which pointed by the front pointers, queue overflow, that means is full, that is when queue is completely full, there is no space, that means the queue is at maximum size, then that is the overflow situation. And underflow, that means there is no element in the queue, and that means the queue is empty, that is the underflow conditions for the queue or underflow operation of the queue, which is also known as the is empty. Then comes to as like stack, we can implement the queue in two different way, that is through array implementation and through linked list implementation. First we will be discuss about the array representation of queue and how can we implementing array, we can insert the element into the queue, and by using array how can we delete the element from the queue. In case of array representation, there are two variables we have already discussed about it, that is front and rear are implemented in the case of every queue. The front and rear variable points to the position where the insertion and deletion are performed. That means the rear will point where the insertion operation will perform and front will point where the deletion operation is performed. Initially the value of the front and the queue is -1. Okay. Initially the value of the front and rear of the queue is -1, which represent that empty of the queue, and we can proceed for the insertion operation. And once we insert the element, then we can delete from it. Array representation of a queue containing suppose 5 element along with respective value of the front and rear, and we will be see how the insertion operation is going on, and when the insertion operation is going on, what will be the value of the rear and front, and when we go for the deletion operation, then what will be the value of front and rear. So this is the array implementation of queue. You can see, suppose our text is hello and array size is maximum, that is 5, that means 6, and we can store maximum 5 element. So these are the position when we insert 1, 2, 3, 4, 5 data into the queue. So when we insert 5 data, the rear became 4 because the array starts from 0 and front will initialize by 0. Okay, rear is 4 and front is 0. And when I want to insert another element into the queue by using array implementation, suppose I want to insert the element that is G, and when I insert G, the rear value is incremented by 1, that rear is 4 before insertion, and when we insert the element G, then the rear became incremented by 1, that is 5, and front remain same. So this is the pictorial representation of queue before insertion of element at 5th position and after insertion of element into the queue. Okay, then we will see the deletion. In case of deletion, you can see, suppose I want to delete. As per our discussion, queue is based on the FIFO principle, that is first in and first out. The element which is to be inserted first into the queue, that will be deleted first from the queue. So you can see H is the element which is inserted first, that is why it will store at the 0th position of the array. So we will be delete this element first, and before deletion the front is 0 and rear is 5. Okay, and after deletion the front will increase from -1 to 0 and it will be represented like this, and rear is remain same. So this is the pictorial representation of the element before deletion of the element H and after deletion of the element H. Then we will see the algorithm and the C function to implement the insertion operation by using array in queue. Okay, in step 1, first we will be check rear equals to maximum size or -1. As we are implementing this queue by using array, we know that the initial array index is 0 and the maximum size of the array is size -1, but in this case we are taking the size as max. So, we will be check if rear equals to max minus 1, that means if this condition is true, then we sure that there is no space to insert a new element. That means the array or the queue is in overflow situation. Then we will be print or write a message that the queue is in overflow condition. If this condition is false, then we will go for step 2. In step 2, we will be check rather any element is stored in the array or queue or not. If this condition is true, that means if front minus 1 and rear minus 1, if both the conditions are true, then we will be set front and rear to the 0th index, and then we will start to insert the element. Okay. So, as this condition is, suppose this condition is true. So, if this condition is true, then we will be set front equals to rear equals to 0, and we will be exit from this to step 3, that is set q of rear equals to num. That means currently where the rear point, we will be store the element or we will be insert the element at that location. You can see is if the rear is 0, then we will be store the new element at the 0th location of the array of the queue. Okay. Suppose this condition is false, that means if front equals to minus 1 and rear equals to minus 1, condition is false. If this condition is false, it means there is some element into the queue, and now you want to insert the new element, and when we insert the new element, we must first increment the rear value, then after we can do our insertion operation. So, when this condition will be false, we will go for the else part of this if, that is else set rear equals to rear plus 1, and when we increment the rear value and where the rear will point at that location, we will be insert our element. Okay. So, set q equals to rear equals to num. So, num is our variable which hold the element, new element which is to be inserted into the queue, and if I write set q of rear, that means where the rear point in the queue, at that location our new element which is stored in the variable num will be stored, and we will be exit by executing step 4. So, in this way we can insert the element into the queue by incrementing the rear value. Okay. This is the algorithm for insertion of any element into the queue, and this is the function implementation of this algorithm. You can see here I am receiving a queue of array and the maximum size of that array and the front and rear value and the item which is to be inserted into the queue. So, you can see in step 1 in algorithm we first check if rear equals to max minus 1. So, if first in function we will be check if rear equals to max plus 1. If this condition is true, it means the queue is in overflow condition. So, we will be print overflow. Otherwise, we will go for the else part, and first we will be check whether any element stored in the queue or not. If front equals to minus 1 and rear equals to minus 1 condition is true, it means there is no element in the queue. Now, we will start to insert the first element into the queue. By setting front equals to 0, rear equals to 0, we will point rear and front both to the 0th index of the queue array. Okay. And then we will be exit from if part and we will be insert queue of rear equals to item. That means the item which was received in the function, that is inserted into the rear current position. If this condition is false, that is if front equals to minus 1 and rear equals to minus 1 condition is false, it means there is some element in queue and we want to insert another element into the queue by incrementing the rear pointer variable. So, we will go for the else part, and in else part we will be increment rear equals to rear plus 1, and where the rear point in the queue, we will be store our new element at that location, and this is the end of the if block and this is the end of the function block. So, this is the algorithm and this is the function implementation for inserting an element into a queue. Next, we will see algorithm to delete an element from the queue. If the value of the front is minus 1 or value of the front is greater than rear, then it is underflow. That means, if front is minus 1, that means there is no element in the queue. If the front is greater than rear, then it is also in underflow condition. So, we will be exit from the queue. Otherwise, keep increase the value of the front and return the item stored at the front and end of the queue at each. So, let us see the algorithm to delete an element from the queue and the function implementation. So, in first step we will be check if front equals to -1 or front is greater than rear, then we will be print the underflow condition for the queue. Otherwise, that means if this condition is false, then we will be go for the else part, and the element which I want to delete from the queue, I will be store that element, that means where the front point, from that location I will be retrieve that element and store in the variable val. Set val equals to queue of front, and then we will be increment the front pointer value, that is front equals to front plus 1, then end of if block. So, in this way we can remove the element from the queue, and in step 2 we will be exit. Okay. This is the algorithm and this is the function implementation. In function implementation, suppose our function is delete and this function is with argument with return type int, then this is the array, queue array, maximum size of the array, front and rear variable, then here I am declaring a variable y. So, as per the algorithm, we will be first check if front equals to -1 or front is greater than rear, then we are in the underflow situation in queue. So, we will be print a message that is queue is underflow. Otherwise, if this condition is false, that means the queue is not in underflow situation, we can now able to delete the element from the queue. So, we will be execute the else part by executing y equals to queue of front. That means where currently point by front variable, we will be remove that element and that element is stored in the variable y. Okay, this is the first one. Then second is if front equals to rear, then we will be set front equals to rear equals to -1. Otherwise, we will go for the else part, front equals to front plus 1. That means we will be increment the front value and we will be exit and return the value of y, which is the element which was delete from the queue, which point by currently a front pointer. So, this is, and in this way we can remove the elements those are present in the queue. So, this is all about your deletion operation in queue by executing this algorithm or by executing this C program function, we can delete the element from the queue. So, this is all about queue operation in data structure. In today's class, we have discussed about the insertion operation or NQ and DQ operations in queue and the array implementation of queue. By using array, how can we insert the element into the queue and how can we delete the element from the queue. In next class, we will be see the linked list implementation of queue. So, till then keep watching. Thank you.